Hello viewers. Now in this tutorial we have question that has to do with density. That's when we talk about aluminium is lighter than lead. We know that lead, okay, is heavier than aluminium. So when we can differentiate, when we can tell that there's a difference of the two materials, so we can say that one material is denser than the other. Just like when we have when we put water, okay, like we put what's it called, water in a container. Okay, let's say a 5 grams container, all right, is filled with water, and we have another 5-gram container filled with palm oil. Now one is called heavy fluid, the other is called light fluid. So that's why when it comes to different types of fluid, we have practical fluid, we have ideal fluid. Okay, we have many types of fluid, but like I said, this is a question about solid and fluid. That is, it's a question that has to do with density of substance. Okay? So now the question reads, this there are many questions we are going to be. I have a lot of questions I received in my mail, and one of the questions I received like 2 days ago was this question that's to do with solid and fluid. Okay, but because of my busy schedule, so I've not been able to to drop a video on this. Okay, now we have, as a first approximation, Earth continent may be thought of as granite blocks, floating in a denser rock called periodotite. Now, in the same way that ice flows in water, now we want to show that a formula describing this phenomenon, this is similar to an ice floating in water. You understand? So which means the granite, okay, the granite block, okay, which is thought of as a continent, floats in a denser rock known as what? Periodotite. So the fluid is the what? Periodotite. Okay. Now the rock, which is, the block, that's the granite, is the what? Is the solid. So that's why the topic is what? Solid and fluid. Okay. Now the first thing we need to understand here is that to be able to set up the problem, okay, we need to understand that there are two principles when it comes to density. Okay, now these two principles, we have a lot of them because there's this aspect of engineering, this course called fluid mechanics and hydraulics. Okay, we have a lot of principles when it comes to buoyancy and all of that. So now, but these two principles are very important, most especially for those of us that we take we're taking what we call college physics, okay, or AP physics and the rest. So now the two principles are, we have the one called the Archimedes principle. Okay, the Archimedes principle states that the weight of fluid displaced, okay, will be equals to the what? The weight of objects. You understand? That is, the weight of objects, okay, will be equals to the weight of fluid displaced. Now, but in the case of buoyancy, that's when we talk about principle of flotation. Now, buoyancy, that's law of buoyancy, or the principle of buoyancy, dictates that the weight of fluid displaced, okay, will be equals to the weight of what? Of the floating object. So that means in the case of Archimedes principle, okay, when an object or a body is partially or completely submerged in a fluid, okay, the weight of fluid displaced will be equals to the weight of the object which is partially submerged or immersed, okay, or completely immersed in the fluid. So that's it. So now, let's look at how we can prove this phenomenon. Now, how we can prove this formula. Now, to prove the formula, so like I said, now granite block is thought of as a what? As the earth, one of the earth continents, okay, floating in a denser rock known as periodotite. Okay, now, so like I said, this is a question which is similar to ice floating in a fluid. Okay, so now let's see how we can prove the formula. Very important. Now, to be able to analyze the problem, okay, like I said, we need to set up the problem. So the first thing we need to do is, now let's think of this as when we have, this is the periodotite, the fluid. You know, we have the fluid, you know, a substance that can flow, that's the fluid. So we have the fluid, okay, and the fluid is the what? Is the periodotite, okay. Now we have the what? The ice, which is the granite. So let's consider a column of granite, okay, a column of granite with which is partially submerged in a fluid, okay, or yes, partially submerged in a fluid or immersed in a fluid. So this is the fluid. So the fluid is what? So this is the granite. Now we have a column of granite. So let's say the cross-sectional area of the granite is what? Is A. So let's A equals to cross-sectional area, that's, let me put that as AG, cross-sectional area of the granite what? Block. Now the thickness, okay, the thickness of the granite is also important, just like what we have here, T. Okay, now let's T equals to thickness of the granite. Let T be equals to the what? The thickness of the granite. So like I said, we have a column of granite, you know, floating in a what? In a fluid. Now the granite, okay, according to the question, okay, is thought of as a what? As one of Earth continents, you know, floating in a denser rock. So the denser rock is the what? The fluid. The denser rock is what we call the periodotite. Okay. So now in this case, so for the granite, you know, for the column of granite floating in the fluid, so we need to what? We are going to apply the principle known as the what? The principle of buoyancy, which dictates that, you know, the weight of the displaced fluid will be equals to the weight of the what? Of the floating object. That is, remember, by applying, okay, first of all, now we can say that volume of granite, Vg, okay, represents volume of granite, okay. So that volume of granite will be area of granite multiplied by what? Its thickness, okay, multiplied by its thickness. Now also we know, let me put it this way, we know that density is what? Mass over volume. So which means mass of granite will be equals to density multiplied by volume of granite. So that means density of granite multiplied by what? Volume of granite. Okay, density of granite multiplied by volume of granite. But here we have, you know, we have, remember, this is Vg, okay, represent volume of granite. So we have mg, okay, to be equals to mass of granite. Mass of granite. So we have mass of granite, but we have volume of granite to be area times what? Thickness. So we then have mass of granite to be density of granite multiplied by area multiplied by what? Thickness. Okay, so this is the mass of granite. Now let's also measure the what? The weight of the what? The granite block. Very important. Weight of granite block. Weight of granite block. So the weight of granite, we know that weight of granite will be mass of granite multiplied by acceleration due to gravity. Remember, G is the what? Acceleration due to what? Acceleration due to gravity. Okay, due to gravity. So now, so we have weight of granite, okay, equals to mass of granite multiplied by what? The acceleration due to gravity. So we have here that the mass of granite is density of granite multiplied by area of granite multiplied by what? Thickness. So we then have the weight of granite to be equals to density of granite, okay, multiplied by area times thickness, then multiplied by what? Acceleration due to gravity. So this is the weight of granite. Okay, weight of granite. So this is the weight of granite. This is very important. Now remember, it is important to analyze the problem, okay, for us to understand that, okay, it's not just about writing this formula, but it's about trying to understand, the question, and to be able to know, to see how the formula can be what can be proven. So now we have weight of granite to be density of granite multiplied by area times thickness times acceleration due to gravity. Now remember I said by applying, so this will come first, sorry. So by applying what we call principle of buoyancy, by applying principle of buoyancy, which dictates or states that, okay, which dictates or states that the weight of the displaced fluid is equal to the weight of the floating object. Okay, weight of the displaced fluid, okay, weight of the displaced fluid is equals to the weight of the floating object. So this is fluid and this is what? Object. So weight of the displaced fluid, okay, weight of the displaced fluid, let me write it boldly, weight of the displaced fluid, okay, is equals to weight of the what? Floating object. Weight of the floating object. So that's what I just explained here, So like I said, we need to consider a column of granite, okay, with area, that's cross-sectional area A, and thickness T. So we know that the thickness of the granite, it will be represented with letter T. The area, the cross-sectional area is A. Now the volume of the granite will be what we have here as, area, volume is area multiplied by height, because we know that area is length times width. So length times width times height, that will be equals to volume. So in this case, the volume of granite will be the cross-sectional area of the granite multiplied by what? The thickness, its thickness. Okay, so and I said we know that density is mass over what? Volume. This is what the Greek letter for density, that's rho. Okay, so we have mass of granite to be equals to density of granite multiplied by volume of granite. That is when we express the mass in terms of density. Now we have mass of granite to be equals to density of granite multiplied by area times thickness, because volume of granite is area multiplied by its thickness. That's area of the granite multiplied by thickness. So here we have the weight of the what? Of the granite. Okay, now also we know that for the fluid, so now let's consider the volume of the fluid displaced by the floating, granite. So we have also, let's consider the weight, the volume of periodotite, which is the fluid, okay, displaced by the floating granite, which is what? Object. So like I said, this is a question which is similar to when we have ice floating in water. All right, so now, let's consider the volume of periodotite, okay, which is a fluid, okay, floating, displaced. So we have this, so volume of fluid displaced. So now, volume of periodotite floating, okay, by the what? By the floating granite, and also the depth to which the what? You can see we have here, D is the depth to which a continent floats. The continent is the what? Granite. And D, okay, the depth to which the continent The continent is what? The granite block floats. Okay, floats in fluid, and the fluid is what? The fluid is what we call the fluid is what? The periodotite. So we don't have, let's say we have volume of periodotite. Volume of periodotite. Okay, now we also have the what? We have the area. This is area of periodotite. Okay, so then we also have the depth. So which means volume will be area times depth. Will be area times depth. So volume of the periodotite is area times depth. Now also we know that density. Now we know that from density equals to mass over volume. So we can say that, so density of periodotite, okay, is equals to mass of periodotite over what? The volume of periodotite. So the mass of periodotite will be what? Will be density of periodotite multiplied by the volume of periodotite. So that's the mass of periodotite. Now, then also we know that weight of periodotite, which is the fluid, okay, which is the fluid, the weight will be Wp. Okay, we know that mass of periodotite times acceleration due to gravity will be equals to weight of periodotite. So we can then say that Wp equals to mass of periodotite is what? Density of periodotite multiplied by the volume. Now the volume is what? The volume is area times depth. Area times depth. Okay. Now multiplied by what? Gravity. So this is the what? This is the weight of the what? Periodotite. Why this is the what? Weight of, this is weight of granite. Okay, this is the weight of periodotite. All right, so now it is now we are now it is now this is when we now apply what we call the Archimedes principle. You know, I said the Archimedes principle states that when an object is partially or completely immersed in a fluid, okay, the weight displaced, I mean the weight of object will be equals to the weight of fluid displaced. That is the weight of the fluid displaced will be equals to the weight of the object. That is the Archimedes principle. So by applying the what? The Archimedes principle. By applying the Archimedes principle, okay, we have weight of objects equals to weight of, or let me put it this way, weight of fluid displaced. Weight of fluid displaced is equal to weight of objects. So weight of periodotite will be equals to weight of what? Granite. That is Wp will be equals to Wg. Now we have Wp to be density of periodotite multiplied by area times depth times gravity. Okay, now Wg, that is the weight of what? Granite. That will now be density of granite multiplied by area times thickness. Okay, then multiplied by what? The acceleration due to gravity. Now we're almost there. Okay, so which means by dividing both sides by g, okay, this equation reduced to density of periodotite area times the depth. Now density of granite multiplied by area times thickness. Now they will have the same, that is the area of the floating object will be equals to the area of the fluid. So that is why I didn't bother to put P in this case. So which means the area of, and that's why I didn't bother to put G in this case as well. So the area will be what? Will be the same. All right. So when we divide both sides by what? By A. Now the equation now reduced to density of granite multiplied by its thickness, then equals to density of periodotite multiplied by what? The depth. So this is the formula. Okay, this is the formula showing the relationship between the density of granite, which is the what? The earth continent, and its thickness. Okay, the earth continent, its thickness, then the density of periodotite, okay, which is a fluid, all right, and the depth to which the what? The floating object, I mean the depth to which the granite floats in the what? In the fluid. The noblest pleasure is the joy of understanding. Bye bye.